Hi friends, welcome to Yuva Guru Maths Theory Lectures. We have theory and practical, two separate types of video lectures. In theory we cover the concepts and in practical we cover the examples. Both this theory and practical together are useful for CBSE, ICSE, various state boards across India and outside India as well. Anyone who wants to understand maths better needs to download this Yuva Guru Maths Olympiad app. So, let's focus on our today's topic, playing with numbers. There is no specific portion to this topic because it's playing with numbers. You can change the numbers, do anything, any operation on the numbers. It's more of a logical thinking. Okay. Numbers in the general form. A two-digit number can always be written in a combination of two different numbers. Means what? 65. Means what is 65? 65 means 60 plus 5. What is 60? 10 into 6 plus 5, right? So 6 is at 10's place and 5 is at 1's place. Similarly 23, same logic. Thus any two-digit number can be written in the form 10 into x plus y. See this, 10 into 6 plus 5. So 10 into x plus y. Similarly for hundreds, the three-digit xyz can be written as 100 into x plus 10 into y plus z. This third number, right? xyz is a number. Getting it? In hundreds place multiply by 100, in thousands place multiply by 1000. Puzzles and games. Now this is again the sort of playing with numbers. Puzzles and games are source of entertainment and education that makes interesting and challenging situations. So reversing the digits of two numbers. Okay, means what? Suppose if it is 65, if I reverse it, then what it becomes? 56. Means what? 10 into 5 plus 6, and earlier it was 10 into 6 plus 5, right? So reversing, choose any two-digit number 10x plus y, reverse the digits, so it becomes yx, 10y plus x. Add the reverse number to the original number. This 10x plus y plus 10y plus x equals to 11x plus 11y. So 11 into x plus y. Divide the answer by 11. You will get 11x plus y upon 11 is x plus y. There is no remainder. So the sum of two-digit numbers and the number form the reversing that the digits is exactly divisible by 11. This is very much important and it comes in the exams. It's always divisible by 11 and the quotient obtained is the sum of the digits of the original two numbers, right? X plus y. Adding both the numbers we get, for example, 36 plus 63, 99, divisible by 11, right? Similarly, subtraction. Choose the digit 10x plus y, reverse it 10y plus x, subtract it 10y plus x minus 10x plus y. Means this minus this. You get 9y minus 9x. So 9 into y minus x. So divisor is 9. So what do you refer from this? The difference between any two-digit numbers and its reversed number is exactly divisible by 9. Right, and the quotient obtained is either the difference of the digits of the original two numbers or 0, either of these two. Okay, reversing a three-digit number, choose the three digits. So 100x plus 10y plus z, right? We earlier said this. From the two more numbers in the way, like y, z and x, reversing. So 100z plus 10x plus y. Add all the three numbers. So 100x plus 10y plus z plus 100y plus 10z plus x, this one. Okay, plus 100z plus 10x plus y means we have reversed this two times, right? So zyx then zxy. Divide the answer by 111. That is 111. So you get it by that it's exactly 111. If you see, add all this, it becomes 111x plus 111y plus 111z. So it's exactly divisible by 111. Thus, the sum of three-digit numbers and the number formed by arranging its digits in such a way that each digit occupies a place value only once is exactly divisible by 111, that is 111, and the quotient obtained is the sum of the digits of the three original three-digit number. So this you have to remember. If you interchange two digit, then by 11. If you interchange three digit, then 111, right? Letters of 4 digits. Now this is separate topic. Every game has some rules. So there are some rules for puzzles also. There are 2 rules for solving them. Each letter in the puzzle must stand for just one digit. Each digit must be represented by just one letter. The first digit of the number cannot be 0. Very important. See this example, solve for Q. You have to find this Q. So answer is given as 501. So how to solve this? Take the units place. Q plus 3 equals to 1. So how can it be 1? It can be 11 here. So 8 plus 3 is 11. So Q should be 8 over here. Check 8 with the other part. So 8 plus 1, 9 plus this 1 carry. So 0. Right. It's matching. So Q equals to 8. Find the digits A, B and C. So how to solve them? For, see this, B into 3 is B only, last. So how can it be B? Try with various numbers. Take B as 2, 2 3s are 6. No, it's not same. Then 5, 5 3s are 15. Yes, it is same. 0, 0 into 3 is 0. Yes, that is also same. So B can be 0 or 5. Now, you got it that either 0 or 5. Now let's start checking. Then A equals to 1. Try with A equals to 1 and B as 0. So what do you get? 10 into 3. You get 0, 3, 0. But C and B are different. So you can't take 0 and this. So this is not possible. Right? C and B are different. So 0 over here and 0 over here. B and C are same over here. It's not possible. Next number. 15 into 3. Right? So you get 0, 4 and 5. Yes, this is possible. For A equals to 2, again the same logic, 25 into 3, let's try 075 and 20 into 3, 060, not possible, right? Therefore, it satisfies this 5 part. Similarly, you try for A equals to 3, A equals to 5, whatever. Once you get the answer in 1 or 2, it's okay. Don't go for further trial and error. Now, test of divisibility. So these are all tests you might have learnt it in your earlier standards also. Some of them are given. In the practical videos we have given it by 11 also, by many other numbers also. So divisibility by 2. So number is divisible by 2 if the units place contains 0 or divisible by 2, that is 2, 4, 6 and 2, 6, 8 and 0. And then only it's divisible by 2. This is quite simple, don't waste your time. Divisibility by 3, add the numbers, it should be digits, it should be divisible by 3. Divisibility by 5, 0 or 5 in the end, okay. Divisibility by 9, sum of digits divisible by 9. Divisibility by 10, digits place 0. There is also divisibility test for 7 and 11. We have given it in our practical videos. So that was a theory for playing with numbers. Download Yuvaguru Maths Olympiad app from Play Store to get these videos, tests, question banks with explanations directly on your mobile. These video lectures contain theory and practical, two separate types of video lectures. In theory we cover the concepts and in practical we cover the examples. Both this theory and practical together are useful for CBSE, ICSE and various state boards across India and outside India as well. Anyone who wants to understand maths better needs to download this Yuvaguru Maths Olympiad app. Follow us on Facebook on this link, WhatsApp us on this number for any query related to purchases. Keep studying, keep watching. Thanks.